Alright, this is USNCO Locals 2024, question number 3. So, how many fluorine atoms are in 135 grams of CF2Cl2? Very easy question, but let's write this out. Okay, so just going to multiply with the molar mass, we can get 2 moles. That's 120.9 grams. Just look at the periodic table. Then, what we do, we look at this, which is CF2Cl2, and these are 2 moles of fluorine for every 1 mole of the entire molecule. So, 2 moles fluorine for 1 mole of CF2Cl2. So this is our molar ratio, and that's what we're going to multiply to get 2 moles of fluorine. 2 moles of fluorine and 1 mole. I'm not writing that out. So now we're in moles fluorine. So to get to atoms, we can multiply by Avogadro's constant. And once you do that, you will get 1.34 times 10 to the 24th. You can do the calculation on a calculator. That's C. Next question. Okay. So I used 2024 penny, which is a mixture of zinc and copper dissolved in dilute nitric acid, forming aqueous Ca2+ and Cn2+ ions. Okay. The resulting solution is treated with an excess of iodide ion, causing the Cu2+ to react to form Cui and I3-. Subsequent titration with disulfate reveals that 4.93 times 10 to the -4th moles of I3- was formed. What is the mass of copper in the penny? There's a lot of information here. Let's go step by step, right? First, our penny, which is Zn plus Cu, is solved in dilute nitric acid. And yeah, so it forms Cu2+ and zinc2+. Then it's treated with iodide ion, I-, and it causes the Cu2+ to react to form Cui and I3-. We don't really need the zinc because that's not even what we're looking for. So I'm just not even going to include it. So that's Cui and I3-. Okay, so subsequent titration with disulfate reveals that 4.92 to the -4th moles of I3- was formed. 10 to the -4th. So we just need to work backwards in these reactions, and we can find mass, right? So 4.93 to the -4th. We have to balance this equation first. It's not balanced. If we look at Cu2+ by iodide to make Cui, there's a charge of 2+ here, and which is still a -1 charge. So we need 2 moles of, or it's like a 1-to-2 ratio. Think of it as like that. 1-to-2. But there's 4 moles of, or 4 atoms of iodine on the other side. So since there has to be a coefficient of 4, then there has to be something which is half of that, right? So that's 2. So that means that for 2 moles of Cu2+, there's going to be 4 moles of I-. And further balancing that, there's going to be 2 moles of Cui. And then we just get out of that. Okay. Now we're looking at this and we see that I3- and Cu2+, that's in a 2-1 ratio, right? 4.93 times 10 to the -4th. That's moles of I3-. And for every 2 moles of Cu2+, we have 1 mole of I3-. Look at this, 1 mole and 2 mole. So now when we do that, 1 and 3 times 2, right? 9.86. Let me move this down a bit, sorry. 9.86 times 10 to the negative 4th moles of CO2 plus. And now, let me look here. Our CO2 plus, now it's be a mole CO2 plus. It's the same moles of copper, right? 1 mole, 1 mole. So, if we have 9.86 times 10 to the negative 4th moles of CO2 plus, we're also going to have 9.86 times 10 to the negative 4th moles of copper. Just like that. So, now we just convert to grams by multiplying by the molar mass, which is, I actually don't know. Where's it? Okay, there. That is 63.546. So, sorry, I'm running out of room. For every 1 mole of Cu. Oh, we're converting to grams, right? Not 0.86. Okay, so that's 2 below, so that's 6.26. 6.26, I think. And 6.26 is somewhat close to 62.7, but let me just check my calculations. Yeah. 52.665 to each 0.7 grams or milligrams. And that's it. Answer is B.